YouTube, Sandre here. Yes, I am making a video finally after, I don't know how long. It's been a while. My life's been a real roller coaster for a while now. Many things have happened and I've had to deal with a lot of stuff. Most of it is good, by the way, so you don't need to be worried about that, but still, it's been a lot that I've had to deal with. But anyway, this video right here, I'm making this because I've had a bunch of half-finished videos on my, hard drive. And some of these are videos where I debunk flat earthers. And so I thought, you know what, I'm just going to take the time and just finish these videos. But since it's been so long since I've uploaded anything, I'm going to just mash all of these videos into one big video. So here you go. I'll see how long this entire video will end up being, but, this is 4 flat earth videos that I'm debunking. And I'm starting with the first one.
Long before the theory of gravity was a glimmer in Isaac Newton's imagination, the natural physics of density and buoyancy already perfectly explained why apples fall down. Quite simply, objects fall or rise based on their relative density to the medium surrounding them. Apples fall because they are denser than the air, while helium balloons rise because they are lighter. No gravity necessary. This is why raindrops fall down through the air, and air bubbles rise up through water. Everything seeks its relative density, and rises or falls until settling accordingly.
Alright, so the problem here is density doesn't make any sense without gravity. Okay? Or rather, why things float or sink doesn't make any sense without gravity, okay? Because gravity provides the vector, okay? And if you don't know what a vector is, if you don't even know that much, you obviously don't know anything about physics at that point, let me just tell you. But basically, the way we calculate density is that we take the mass of the object, okay? And we divide that with the volume of the object, okay? And so usually, in physics at least, we use kilograms as the international unit for mass, and we use meters cubed as the standard unit for volume. So usually density is measured in the amount of kilograms per cubic meters, okay? So liquid water at 20 degrees Celsius is about 997 kilograms per cubic meters, I think. So almost a metric ton, okay? Now, the thing is, though, in order for things to either float or to sink, there needs to be a vector, okay? Like, if we look at this from a classical mechanical perspective, okay, so we use Newtonian mechanics here. So let's say that you have a beach ball, okay, and let's say that you're swimming in the ocean, and let's say that you bring the beach ball down into the ocean water, and then you let it go, and then obviously it's gonna float up, and then it's gonna go upwards, and it's gonna float at the surface of the water, right? And the buoyancy force is always gonna counteract another force. Just like when you drop something that doesn't float in water. Let's take that let's take an iron chain or something, like something really dense, okay? So you take this chain made out of iron, and you bring it down into the ocean water, and then you let it go, and obviously it's going to fall to the bottom of the ocean. Why does it do that? Why? Okay? Now, you say that things seek their own density, okay, but what does that actually entail? Like, you guys never provide an actual physical mechanism to explain this. Because you can't, okay? It's that simple. You simply cannot provide an actual physical mechanism to explain why when something floats, it always goes upwards, and why when something sinks, it always goes downwards, okay? Like, explain to me the orientation of the vectors. Because the only reason that the buoyancy force, that its vector points upwards when you drop the beach ball and it floats to the surface, the only reason that it points upwards is because it's directly counteracting another force pointing downwards. The force, which, by the way, is holding the ocean water down on the ocean floor to begin with, as well as you when you're standing in at the bottom of the ocean dropping the beach ball, okay? That force, it doesn't matter what you call that force, okay? You can call it the Teletubby force. You can call it like, I don't know, the magical space wizard force, okay? You can call it the divine ether for all I care. It doesn't matter. The point is that force is gravity. And even if you don't believe in the force of gravity, you have to, in order for any of this to make any fucking sense, you have to invoke a force upon which the buoyancy force counteracts. This is the only way you can explain the direction of the vector of the buoyancy force. Why things, when they float, they go up from your perspective, or when things sink, they go down. Now, of course, to anyone who has any, like even just a middle school level of understanding of physics, understands that in reality, things when they float, they don't go up, okay? Nor do they go down when they sink. There is no universal up or down, okay? They either move away from the center of mass of the Earth, or they move towards the center of the mass of the Earth, okay? So yes, it is true that things, seek to be in the medium that has the same density as the thing does. That is true. Why though? Why is that? In order to explain that, you have to invoke forces. Forces have vectors. They point to things. And in order to explain that, you have to invoke these forces. And the only way to explain why you're always witnessing things that float, they move up from your perspective, okay? Again, there is no universal up, but from your perspective, it's going to look like it's moving up. And when things sink, they always move down from your perspective. The reason they do that is because you have forces that pull on these objects. Okay, this is gravitational force, and you have another force that counteracts that force. That's the buoyancy force. I've hardly started this video and I'm already on a tangent. Okay, this is going to be interesting.
Submarines float on the surface when their ballast tanks are filled with air, but when the vents are opened and seawater floods in, they begin to sink as the submarine's density becomes greater than water. We can also prove this fact of relative density by filling a plastic balloon with approximately half helium and half air. Since helium is lighter than the oxygen, nitrogen, and other gases that compose the air around us, filling a balloon with just the right amount of helium to compensate for and balance out the density of the plastic results in a gravity-defying, levitating balloon at equilibrium that neither rises nor falls.
Okay, so since I am a teacher, I'm going to be kind enough to this flat earther that I just verbally scolded. But I'm going to be kind enough to this person who has very strange ideas about how heavenly bodies work in the universe and forces. But anyway, I'm going to be kind enough to this person, and I'm going to do what I do as a teacher all the time to my students, okay? I'm going to give you a demonstration, okay? So I'm gonna film a video that I'm gonna, splice in here in the editing. And, I'm gonna ask you a simple question, okay? So you see this object that I'm holding in the video. And, how can I calculate what the velocity is of this object when I'm dropping it to the floor, okay? I want you to really think about this, like really think this through, okay? Because you can make guesses and all that, but what you're gonna find is you will inevitably, mathematically find that the formula that can explain this looks like this, okay? You can't really get away from it. Whenever you use this formula, you will be more or less 100% correct. You might be off by 1 or 2% here and there. That has more to do with the problems of accurately measuring the time exactly, more than anything. But yeah, if you take an object that isn't going to have too much, air resistance as it falls down to the ground, and if you do that, you have this formula, and you can calculate how fast something is going to be falling when it's making contact with the floor, okay? And in order to calculate that, you will always arrive at this equation. And do you notice something about this, okay? So this A here, this is acceleration, okay? And flat earthers, I know you guys have no problem with the concept of acceleration in itself, okay? I know you don't have a problem with this at all right? But for some reason, when it comes to gravity, all of a sudden you do. But no, that's really all this is. Like, you will find that the acceleration is always going to be 9.8 something meters per second squared. Like, in the latitudes where I live, it's roughly 9.82 meters per second squared. If you live at the equator, it's going to be 9.78 meters per second square. But on average, we usually use the value of 9.8 meters per second squared. But you're going to find that the acceleration, which we can call little g of the object, is always going to be 9.8 roughly. You can't get away from this. What is the definition of a force in classical mechanics? Come on, say it with me now. Mass times acceleration. We know what the acceleration is. We can measure it over and over and over and over again. Which means what? Well, since the object obviously has a mass, a force is acting on it. That force is... Take it away, Dissert File.
Gravity, you fucking retard! Gravity! Have you ever heard of fucking gravity? Gravity! Gravity!
This also explains, very simply, why even in a vacuum, things fall. Since little g, which is the Earth's gravitational constant, okay, which varies a little bit by latitude, but is roughly 9.8 meters per second squared. Now, since that one remains pretty much the same, well, it doesn't matter what the mass of the object is, okay? If you disregard air resistance, no matter how heavy an object is, it's always going to fall with the same acceleration and hence the same speed after a certain distance or fall height as a lighter or heavier object. Okay, so you could compare a grand piano, okay, let's say that you drop it in a vacuum, okay, you can compare a grand piano weighing easily the same as, 10 grown men, like let's say a metric ton, okay? You can compare that with a tennis ball. Okay, again, this is a vacuum here, so no air resistance. they will, if they fall from the same height, reach the ground at the same time. They will accelerate and have the same velocity at the same time. The extra mass of the piano doesn't make a lick of difference. Which flies straight in the face of your idea of density. It's just density, guys! Guy, you globe earthers are so stupid! Don't you understand? It's just density! It's just density! So things seek their own density! That's why things fall afloat! God, I have to say it's kind of therapeutic to make these types of videos sometimes. Just get to flex my physics knowledge.
To begin with, a feather and an anvil will both fall at different rates because one is radically denser than the medium surrounding, air, while the other is not. A dandelion seed and a brick, or a piece of paper and a boulder. These examples and many others fall at drastically different rates, debunking the supposed uniform speed of acceleration due to gravity of 9.81 meters per second squared.
Alright, all of the objects you're talking about here, they obviously behave very differently in terms of aerodynamics. By the way, aerodynamics, in case you don't understand, which, again, this is also another thing that a lot of flat earthers don't seem to understand. Aerodynamics is the study of how fluids interact with other matter. So it can be either that they interact with other fluids, or they can interact with, solids and whatever. By the way, a fluid, in this physical sense, doesn't have to be a liquid. It can also be a gas, all right? But basically, it's the study of how fluids physically interact with other matter, okay? So either other fluids or solid objects traveling through the fluid, basically. There are principles of aerodynamics we can use to understand things, like ballistics, the study of projectiles, how they move, is based on aerodynamics to a large extent. The entire field of aviation is based on aerodynamics, right? But yeah, look, obviously a feather, which is a product of millions of years of evolution, where some dinosaurs started to develop scales that were longer than other scales, and eventually they started to have off-branchings, and eventually feathers arose from that with enough generations. Feathers are literally evolved to, amass as much of a pillow of air around the feather as possible, in order to provide lift. Obviously, a feather is going to behave differently aerodynamically compared to a fucking bowling ball. It's like these flat earthers, they just do not. How do these people get up in the morning and put on clothes? I do not understand this. What is this?
Of air is removed completely, so all objects, including a feather and a bowling ball, will fall at this same maximum rate. By removing the medium from the equation altogether, all objects, including a helium balloon, will fall to the ground simultaneously. Without any medium to move through, the fall rate of all objects is indeed equal, but this has nothing to do with some mythical attractive pulling force, and everything to do with the fact that the density of the surrounding medium has been reduced to zero. Therefore, in reality, since a feather, bowling ball, or anything else inside a vacuum chamber is infinitely denser than empty space, which has a density of zero, it all falls at the same rate of 9.81 meters per second squared.
Again, trying to invoke some strange medium or lack of medium, and saying that, one is infinitely more dense than the other, because, if you have literally nothing, that's zero density, right, guys? So mathematically it makes sense. Okay, look, again, then, again, why then do these objects fall and fall at the same acceleration and the same speed? In a vacuum. This is so stupid! God.
Pumice into a pond. All rocks, excluding the pumice stone, will sink to the bottom. But then when you throw in the pumice, it will rise right back to the surface. This is because pumice has a density less than water, just like helium balloons have a density less than air.
Okay, I mean, you're just kind of repeating, like you're parroting the same point over and over again, and I'm not going to bother going through this again because like I've already killed a bunch of brain cells. But what I am going to point out here is, again, in this model of yours, which, I mean, it's not even really a model, it's more just a hand waving of the facts, but in this setup you have, it still does not explain why when a balloon rises, it rises always upwards from your perspective. And when something sinks, it always sinks downwards from your perspective. Again, you have not explained why things don't move sideways and whatnot. Like, why are there these arbitrary ups and downs, so to speak? You can't really explain that with your framework. But that is, however, not just explainable, but downright intuitive if you invoke a force like gravity. Then it makes perfect sense all of a sudden. And not only that, we can actually do the math and make perfect predictions. Crazy, I know, right? Anyway, I've had enough of this video. Let's move on to the next one.
Recently, however, a few flat earthers have revived Leo Ferrari's old Flat Earth Society claim that the world is not, in fact, a level motionless plane, but rather a constantly upwards rising plane. These people cite experiments such as a helium balloon moving forward in an accelerating car. The only possible way to explain these results is to assume Earth to be constantly rising at 9.8 meters per second, or approximately 22 miles per hour, straight upwards. There is some debate amongst them regarding whether this upward motion is a constant velocity or an acceleration.
All right. Okay. I have to interject here. Okay, first of all, to even entertain this idea that the Earth is accelerating upwards at 9.8 meters per second squared. By the way, you said 9.8 meters per second. It could be a simple slip of the tongue. But no, that would be velocity. What you're talking about is acceleration. So actually, it's 9.8 meters per second squared. Okay, just want to make that clear. That is acceleration. If you don't have that second squared, then it's velocity. All right. So, but anyway, the point is to even entertain this idea that the Earth is accelerating upwards. Which, again, you say, another thing that drives me crazy, you say, oh, upwards motion or acceleration. No, acceleration happens because of motion. So it entails motion. Anyway, like, my God, these people don't know the fucking basics, do they? It's so infuriating.
But these new upward rising earthers have all recently come into agreement that our flat Earth can no longer be stationary. These upward rising earthers begin their inquiry innocently enough by asking questions about the directional vector of dropped objects, and why dense objects fall downwards rather than upwards or sideways, for example. There is a pressure gradient formed by the amount of stacked air, water, or land over you in a column, which increases the pressure, weight, and density the farther down you go, and that defines direction. Unsatisfied with this answer, upward rising earthers by asking, why then does Earth have a pressure gradient stacked in this particular fashion, with the densest layer at the bottom rather than the top or sides? Now, at this point, I would say such a line of questioning is tantamount to asking, why is water wet? Or why is fire hot? It's like asking, why don't we walk upside down on the sky and look up to the ground? It's similar to asking, why don't our arms grow out of our pelvis and legs grow out of our torso? As anyone who has spent significant time with a 4-year-old knows, the question of, but why, if asked long enough, eventually leads to an infinite regress of explanations that can only be ended with the true but potentially unsatisfying metaphysical answer of, it is that way because that's how it was created to be.
That's silly enough, but now you're also like begging the question when you say, "Oh, that's just the way it was created." What? No, it's the way it is. Okay, it doesn't mean that it was created by a creator. That's something that you artificially insert. It's not a certainty. Okay, and that's because you obviously have some kind of, religious bent when it comes to all of this. Most of flat earthers do, I notice. But yeah, and also your attitude towards asking a lot of these questions in the first place is just kind of, disturbing. It shows a lack of imagination and curiosity. It's like asking why water is wet and why fire is hot, blah, blah. What's wrong with those questions? I don't get it. It's like, sure, we know why all of this is, but there's nothing wrong with asking those questions, which is kind of funny, because aren't you supposed to be all about, wrecking the status quo, replacing the status quo, revolting against big science? I don't know. You people are all fucking hypocrites. I notice this over and over again. It's really tiring at this point.
Rather than accept that Earth was simply created to have the particular arrangement of density layering that it does, upward rising Earthers instead claim that Earth must be a constantly upwards rising plane, and that this constant vertical motion is the only thing that can explain the directional vector. Now, while this could make for an interesting speculation, the fact of the matter is that dropping a water bottle with a cork in it, or watching a helium balloon go forward in a moving car, are not demonstrations of the Earth constantly rising upwards. These demonstrations provide tangential evidence for their line of questioning, but in no way prove their assumption that Earth is a constantly rising plane. In fact, upward rising Earthers are forced to pile assumption upon assumption in order to defend their new dogma.
Oh man, it's so funny when one of these flat earthers actually, I just love the condescension from this guy. I just love how this guy feels that he is so much superior to those silly flat earthers who believe that the Earth is rising, just accelerating nonstop at 9.8 meters per second, even though it's 9.8 meters per second squared. That's acceleration, not velocity. But I just love it when these, let's be honest, let's call these people what they are: intellectual invalids. Okay? I'm just gonna say it, these people are mentally retarded. I don't, I don't mean that as in, they have an actual, learning disability, or they have an actual intellectual problem. No, a lot of these people are actually capable of understanding the physics of this stuff, if they just bothered. But they are willfully ignorant. And look, I don't care what people say. I don't care if people think that the so-called R word is offensive or whatever. No, but that's retarded. That's retarded, okay? It's retarded thinking. These people are retarded. You hear me? Retarded. That's what they are. Hashtag cancel Sandre 2024. Actually, if I ran for president, that's probably what I would say. Hey, them flat earthers, they're retarded. It's like I don't even know what I'm saying anymore. Okay, so okay, so let me see if I get this straight. So these flat earthers that you don't like, the other type of flat earther, they actually try. Like I have to give those guys credit. The ones who believe that the Earth is accelerating upwards, you know, at 9.8 meters per second squared, not 8.8, not 9.8 meters per second, like you said. You know, and you're supposed to be such a Mr. Smarty Pants. But no, so those flat earthers actually try, like they at least try to do some kind of experiment to, you know, to prove their case. Now, I mean, look, obviously they're still misguided because, I mean, science is not really about proving anything, it's about disproving things, okay? Like this is one of the key things that I teach my students in the classroom. You know, hey guys, just so you know, when you do these elaborations with me, you know, whether it's in the chemistry lab or it's in the physics lab, you know, just know the goal is not to prove anything; it's to actually try and disprove stuff. Okay, that's what we do in science. Modern science is built on the idea of falsification, and. You know, so those guys are misguided in that sense. They're already off the mark, but at least they put in the effort. At least they try. I mean, they fail miserably. It's kind of like watching, you know, a fish out of water just, you know, flailing around on the deck of a ship, being hopelessly out of water, out of its elements. And not being able to withstand, you know, the air pressure, slowly feeling its own eyeballs expanding as it usually lives, you know, tens of feet below the water, and it's slowly being suffocated by the lack of oxygen that it can obtain through its gills. You flat earthers are basically like that. Whenever you try to step into the arena of science, that's always what we witness. And I mean, you know, like on one hand, it's frustrating because there are some people who actually are taken in by you. I don't know why. I don't know why. Like your stuff is always very easy to disprove, but you know that's what we witness. And as someone who's actually, you know, who actually has degrees in this stuff, you know, I've actually studied science, I've studied chemistry, and I've studied physics at uni. To me, to people like me, not to mention that I also work, my job is literally to teach this to my students. To people like me, it's entertainment. So it's frustrating, but it's also funny. And I mean, it offers me a chance to make content for my subscribers. So I mean, there you go. Circle of life complete, I guess. But make no mistake, after you're done flailing around on that deck of a ship, I am going to flail you, and I am going to roast you over a fire, and I am going to eat you up. Because, you know, prey like you is just lunch to predators like me. Yummy, yummy in my goddamn tummy. Alright, anyway, I've had enough of this. Let's move on to the next video. So this one is apparently about the Doppler effect. So I haven't heard about this in the flat earth circles before, so this is going to be interesting.
In the middle part of the 19th century, a man named Christian Doppler noticed that objects that emitted sound would produce either a rising or falling pitch to an observer, depending on the movement of the object relative to the observer. We know this today as the Doppler effect. Late in the 20th century, we merged radar technology with the Doppler effect, and we came up with Doppler radar, which is currently on your screen. Moisture shows up on Doppler radar much like it does on traditional radar, with one large exception, which makes Doppler radar superior. The Doppler radar unit detects the direction in which the moisture is moving. No computation or compensation built in for the direction in which the signal is returned. In other words, an object moving toward the radar unit will shift the image towards green if the precipitation is moving toward the unit itself. It doesn't matter if the returned image is to the north or to the south or to the east or west. The Doppler radar unit is stationary and treats all returning signals alike, regardless of the directional source of the returned signal. And thus, with the spinning ball Earth that we are told exists, we've got a big problem. You see, if the Earth is rotating at somewhere between 750 to 1,000 miles per hour to the east, depending on the latitude of the radar unit, the Doppler effect would be totally negated by the Earth's rotation. Any echoes from the west would necessarily be moving away from the Doppler unit at 750 to 1,000 miles per hour, plus or minus the actual speed of the moisture that's moving itself, while echoes to the east would be rushing toward the radar unit at the same speed. All the other angles in between would create an almost infinite and nightmarish computation for the radar unit to sift through in order to make sense of the echoes received.
Oh. Oh my god, it's so cute. Look at him trying to do science. Well, at least an attempt was made. I mean, honestly, I should respond to flat Earth content more. To be honest, this stuff is gold. It's like, oh well, if the Earth is spinning at this rate, like obviously there should be a problem with picking up the signals. Blah 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 blah. Okay, my guy, my brother in Christ. Look, I'm not a Christian. I'm actually an atheist. For those of you who don't know, so I just love saying that. I just think it's funny, like my brother in Christ. Dude, okay. Ever heard of something called momentum? Okay. Especially angular momentum, okay? Now, here's the thing. Things, okay, so the Earth is spinning, right? And things that are held down on the Earth's surface thanks to gravity also spin with the Earth. In fact, it's not just the things that are held in place by the ground, such as trees and roads and, lampposts and you and I and, anything else that's on the ground, the mountain chains, whatever the hell you want to bring up. It's not just that stuff that is, moving along with the spin of the Earth, okay? The atmosphere is as well, okay? In fact, the Coriolis force, which is, an atmospheric phenomena that we can witness, which drives, climate, is because of this. Okay, for instance, like the air that's straight above the equator is moving at a much faster rate than the air that's moving, to the north or south of the equator. Which means that if you have a cloud that forms around the equator, and if it moves either up, north of the equator or south, it's gonna impact the way it moves. Okay, like this is why. Well, at least one of the reasons why you even have, different climates around the Earth. It's the Coriolis force, which is a direct consequence from momentum and the Earth's spin. So if you bounce anything in our atmosphere with you know, if you have a radar and you bounce anything within our atmosphere, that thing that you bounce off of, it's already going to follow the spin of the Earth. So what you're talking about is not a concern. Again, you would know all of this if you had actually paid attention in physics class in middle school. You know, it's I don't know, maybe you were one of the kids who wrote the short bus. I don't know.
The bottom line is, there is no computation or correction for any Earth movement whatsoever. The radar unit interprets all echoes the same, regardless of the compass direction. Doppler radar would be a total impossibility on a moving Earth. It simply would not exist. It would not and could not work if the Earth is a spinning ball.
I mean, see, you say that, but you contradict yourself. Like, I mean, I don't even need to say anything here, novel on my own here. Like, I can just point out what you said before. You said yourself previously that the moisture needs to move with the radar. So you seem to acknowledge that things move with the spin of the Earth. Like, dude, like, do you think before you speak here? All right, let's move on to the next video. All right, you know, okay, I think this is a video that I was supposed to debunk, like over a year and a half ago or something. So yeah, it might be as much as 2 years ago. I don't know. It's a long time ago, regardless. But yeah. Apparently, this YouTuber has hired that presenter guy that you can hire. I think he's on Fiverr or something, and you can hire him and do presentations for you. Yeah, so she or he has hired him and is presenting the video for them. But anyway, let's go.
What we know to be true from what we simply believe to be true. Some people turn to science for help with this, but real science can never offer us truth.
Oh, okay. So when it comes to I hate when these people bring up concepts like truth and whatnot, because it's like, look, I don't even deal with concepts like truth. To me, truth doesn't really matter in science. Like, we don't talk about truth in science to begin with. We talk about, okay, what has evidence and what has not. What can be disproven and what can't. And what has, withstood attempts at being disproven over and over and over again. Like, you form a hypothesis and then you try to mercilessly, and I do mean mercilessly, disprove that hypothesis. And if you just can't, and you've thrown everything and the kitchen sink at it, okay? If you've done anything you can to try and disprove that hypothesis, then eventually it may be upgraded to a so-called theory. Which simply just means that it's withstood being disproven. Okay, it's held up under falsification. Doesn't mean that it's the truth. It just means that it's a model that has not been able to be disproven. So it's probably very close to the truth, but there is no claim that it is the truth. Okay? So this concept of truth is something you have to put aside in science. Like, are we getting closer and closer to the so-called truth, with our models being improved? Sure. We can't claim to have the truth. And that's fine. That's fine. That's perfectly fine.
The best science can ever say is, here's a useful theory that seems to describe the elements of our world in a way in which it's useful to us for our current purposes. The conclusions drawn aren't truth. They're simply our best understanding of our reality based on the limited information we have available to us in this particular moment. Science can look at swans and collect data about their color. The collected data can be analyzed, put through a statistical analysis software, interpreted through ideas about colors and feathers, and from this, we can draw the conclusion that all swans are white. We can replicate this study and come to the same conclusion again and again. And then some lunatic from the lunatic fringe might come along claiming to have seen a black swan. Crazy black swan conspiracy theorists. So science, as it's practiced today, will ignore him or simply mock him and ridicule him because we don't have the time for a meeting of the Black Swan Society.
Okay, so you're basically, perverting this whole black swan, white swan allegory that is, very much attached to the idea of falsification. The whole idea of this allegory to begin with is simply that, look, science needs to be falsifiable. Like, modern science is built on falsification. The whole idea behind it is that, let's say that all the swans that we have, observed so far are white, okay? So we then have a hypothesis that all the swans are white, okay? If we then observe a swan that is black, obviously we've just, just like that, we've disproven the hypothesis that all swans are white, okay? So that's disproven. That it's been falsified, okay? We have to make a correction. Then we can say, okay, most swans are white, right? That would be accurate. So now we have improved our model, okay? We've improved our hypothesis because it didn't cut the mustard originally. It didn't take into account the nuances of the world, if you will, the complexities, if you will. But that's what this allegory is supposed to represent. It's not supposed to represent what you think it does. So either you don't understand the whole point of this allegory to begin with, or you know what it is and you're just cynically trying to pervert it on purpose to mislead your viewers. In that case, you are just absolutely rotten to the core, a terrible human being, I have to say. I think it is absolutely vile to try and mislead people on purpose like that. I think people who do that are the lowest of the low, just like people who play music loudly on the bus. It's like, have you people heard of something called headphones or earbuds? Like, why do you play music on the phone so everyone can hear it? Like, why? So yeah, I'm lumping you in with those people. Or, those people who fart in elevators and think that nobody notices. No, people notice, pal. Like, people notice, and it fucking smells. Okay, it fucking smells. Okay, and everyone knows that you did it. Okay, like don't try to fucking pretend like it didn't happen. It did. Everyone, like, you really have no control of your bowels. Like, you can't wait until you're back in your apartment before you decide to, like, release wind. I just and what else? People who walk their dogs but don't pick up the dog shit. Okay, I'm lumping you in with those people as well. Like, that's the level you're at, okay? That's the level you're at, Susan. Like, I don't know if your name is Susan. I'm assuming your name is Susan, okay? I don't know. You strike me as a person who's named Susan. So yeah, that's the kind of person you are, Susan. The kind of person who doesn't pick up the dog shit, and yeah, that's I'm just gonna leave it at that. You're the lowest of the low. Where am I going with this? I don't know. This material literally kills your brain cells. yeah, I need a break. Okay, and besides, I think this is going to be long enough. This video anyway. I need to edit this stuff together so I can put it up in time. But yeah, I'm going to end it here. This is not going anywhere. And I'm going to have a nice alcoholic beverage because I think I deserve that at this point. And thank you all for watching. I hope to be making more content, from now on. All the videos that I've advertised before, such as the one on the Ukraine war and whatever, like all these videos are still in the works. Don't worry about it. They will be up at some point. I really wish I could tell you exactly when, but I really don't. One thing is clear. Originally, I had intended for these videos to be, just one big video. But, I mean, that's not going to work now. There's just way too much content. I'm going to have to split them up into smaller parts. And even that is a bit complicated, though, because like things keep happening in the war. With the Ukraine war, for instance. And also now you have the situation in Gaza where Israel is bombing the crap out of the civilian population, which it's a war crime. It's a war crime. It is what it is. So Israel is committing war crimes. Hamas committed war crimes. Everyone's committing war crimes. Russia commits war crimes. Israel commits war crimes. Hamas commits war crimes. It's a war crime bonanza. Like everybody's committing war crimes these days. It's the latest fad, it seems. Where was I? Oh yeah, look, all these videos are going to be up at some point, but yeah, we'll see when. Anyway, I hope you enjoyed this video. Sorry for the rambling, but yeah, take care, guys.